So this session is sixth session. Till now we have completed 5 sessions, and in the previous 5 sessions we have covered the definition of stress, types of stresses, and stress strain diagram for ductile material and brittle materials. And also we have seen the Poisson's ratio, the relation between the elastic constants and different types of elastic constants. So we have studied all these concepts in the previous five sessions, and also we have solved some of the problems on the above concepts. So now we will solve some more problems on the simple stresses and strains concepts, right? So that is a simple problems from session 1 to session 4. Session 1 to session 4 means in the session 1 and 4 up to 4 sessions. So what and all we have covered the concepts based on that formula, and based on that definitions, we need to solve some more problems, because this strength of material is a maximum the problematic subject. It is a only 30% theory will be there, 70% the problems will be there. So maximum problems comes on this subject. So we will concentrate more on problems rather than concentrating on the theory, right? So in this session, first we will see, so what is the first problem here? So this is the first problem. So in this first problem, I have picked this problem from the RS Kurmi reference book, right? So the problem, it is 9. Till now we have solved 8 problems. So this is the 9th problem. So 2 wires, one of steel and the other of copper, are of same length and are subjected to the same tension. If the diameter of copper wire is 2 mm, find the diameter of the steel wire if they are elongated by the same amount. Take E for steel as 200 gigapascal and that for copper as 100 gigapascal, right? So this is the given problem. So once again, read it the problem carefully, right? ಸೊ ನಾನು ಯಾವಾಗ ಪ್ರಾಬ್ಲಮ್ ಓದ್ತಾ ಇರ್ತೀನೋ ನೀವು ಅವಾಗ ಪ್ರಾಬ್ಲಮ್ ಓದ್ರಿ, ಅಂದ್ರೆ ಅರ್ಥ ಆಗುತ್ತಾ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಏನ್ ಕೊಟ್ಟಿದ್ದಾನೆ ಮತ್ತೆ ಏನ್ ಕೇಳ್ತಾ ಇದ್ದಾನೆ. ಸೊ ಅದು ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್. ಅವ ಏನ್ ಕೊಟ್ಟಿದ್ದಾನೆ ಏನ್ ಕೇಳ್ತಾ ಇದ್ದಾನೆ ಇವೆರಡೂ ನಮ್ಗೆ ಅರ್ಥ ಆಯ್ತು ಅಂದ್ರೆ ಪ್ರಾಬ್ಲಮ್ ಅನ್ನ ನಾವು ಈಸಿಯಾಗಿ ಸಾಲ್ವ್ ಮಾಡಬಹುದು. ಸೊ ಅದು ಬಹಳ ಮುಖ್ಯ. ಸೊ ಐ ವಿಲ್ ರೀಡ್ ಒನ್ಸ್ ಅಗೇನ್, ಯು ಆಲ್ಸೋ ರೀಡ್ ಅಲಾಂಗ್ ವಿತ್ ಮೀ. 2 wires, one of steel and the other of copper, are of the same length and are subjected to the same tension. Same tension means load, same load. ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾನೆ, 2 ವೈರ್ ಇದೆ, ಒಂದು ಸ್ಟೀಲ್ ಇಂದ ಮಾಡೈತಿ, ಇನ್ನೊಂದು ಕಾಪರ್ ಇಂದ ಮಾಡ್ಯಾರ. ಬಟ್ ಎರಡ್ರದ್ದು ಮೇಲೂ ನೀವು ಟೆನ್ಷನ್ ಹಾಕ್ತಾ ಇದ್ರಿ. ಟೆನ್ಷನ್ ಇಸ್ ಬಟ್ ಲೋಡ್. ಎಷ್ಟು ಲೋಡ್ ಹಾಕ್ತಿರಿ ಎರಡ್ರ ಮೇಲೆ ಅಂದ್ರೆ ಸೇಮ್ ಅಂತ ಹೇಳ್ತಾನೆ. 2 ವೈರ್ ಮೇಲೆ ಸೇಮ್ ಲೋಡ್ ಹಾಕ್ತಾ ಇದ್ದೀವಿ. ಇಫ್ ದ ಡಯಾಮೀಟರ್ ಆಫ್ ದ ಕಾಪರ್ ವೈರ್ is 2 mm, ಕಾಪರ್ ವೈರ್ ಡಯಾಮೀಟರ್ 2 mm ಇದ್ದಾಗ ಫೈಂಡ್ ದಿ ಡಯಾಮೀಟರ್ ಆಫ್ ದ ಸ್ಟೀಲ್ ವೈರ್. ಅವಾಗ ಸ್ಟೀಲ್ ವೈರ್ ಡಯಾಮೀಟರ್ ನಾವು ಕಂಡಿಡ್ಬೇಕು. ಅದು ಕೇಳ್ತಾ ಇದ್ದಾನೆ ನಾವು. ಬಟ್ ಅದನ್ನ ಕಂಡಿಡ್ಲಿಕ್ಕೆ ಈ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲೇನೆ ಕಂಡೀಷನ್ ಕೊಟ್ಟಿದ್ದಾನವ. ಏನ್ ಕೊಟ್ಟಿದ್ದಾನೆ ಅಂದ್ರೆ ಸೇಮ್ ಲೆಂತ್ ಅದಾವ 2 ವೈರು ಮತ್ತು ಲೋಡುನು ಸೇಮ್ ಅದ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾನೆ. ಅಂಡ್ ಇಫ್ ದೇ ಆರ್ ಎಲಾಂಗೇಟೆಡ್ ಬೈ ದ ಸೇಮ್ ಅಮೌಂಟ್, ಮತ್ತೊಂದು ಕೊಟ್ಟ, if they are elongated by the same amount. Same amount, elongation means change in length. That is elongation or change in length or deformation. 3 words are same. So if they are elongated by the same amount, andre change in length nu same ide. So take E. E means what? Young's modulus. Young's modulus for steel as 200 gigapascal and that for copper as 100 gigapascal. Andre E steel material ಗೆ 200 gigapascal ಐತಿ, ಕಾಪರ್ ಮೆಟೀರಿಯಲ್ ಗೆ 100 gigapascal ಐತಿ. So whenever the material changes, the Young's modulus changes because the load carrying capacity of that material changes. So ಯಾವಾಗ ಮೆಟೀರಿಯಲ್ ಚೇಂಜ್ ಆಗುತ್ತೋ ಅವಾಗ ಆ ಲೋಡ್ ಹಾಕ್ತಕ್ಕಂಥದ್ದು ವ್ಯಾಲ್ಯೂ ಕೂಡ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ ಅದಕ್ಕೆ. ಸೊ ಅದು ಕೊಟ್ಟಿದ್ದಾನೆ ನಿಮಗೆ. ಈಗ ರೈಟ್ ಇಟ್ ದ ಸೊಲ್ಯೂಷನ್. ಸೊ ವಾಟ್ ಇಸ್ ದ ಗಿವನ್? ಈ ಪ್ರಾಬ್ಲಮ್ ಇಂದ ನಾವು ಏನ್ ಅರ್ಥ ಮಾಡ್ಕೊಂಡಿದೀವಿ, ಏನ್ ಕೊಟ್ಟಿದ್ದಾನೆ ಅನ್ನೋದನ್ನ ಬರೆಯೋಣ ಫಸ್ಟ್ ಅಲ್ಲಿ. Diameter of copper wire, it is given, that is 2 mm. So modulus of elasticity for steel, so ES, capital ES ಅಂತ ಕೆಳಗಡೆ S ಬಂದ್ರೆ ಸ್ಟೀಲ್ ಮಟೀರಿಯಲ್ ದು Young's modulus ಅನ್ನಂಗಿದೆ. It is 200 gigapascal. So 200 gigapascal, giga means 10 to the power of 9, pascal means it is 10 to the power of Pascal means Newton per meter square. So now I have converted this into Newton per mm square. So that is 200 into 10 to the power of 3. Actually 10 to the power of 9 Newton per meter square agata. So a meter square nu naven madbeki mm square madadaga 10 to the power of 6 hoguttali. So 10 to the power of 3 ashtu ulidide. So 200 into 10 to the power of 3 Newton per mm square. And modulus of elasticity for copper. So capital E small c means it is Young's modulus of copper material. That is 100 gigapascal. So this is equal to 100 into 10 to the power of 3. It should come at the top. 3 should come at the top. It is 3 This is 10 to the power of 3, not at the bottom. So 10 to the power of 3 Newton per mm square. So let ds diameter of the steel wire. So then L is length of both the wires. P is tension applied on both the wires. You ಮೂರನ್ನ ಕೊಟ್ಟಿಲ್ಲವ ಬಟ್ ಹೇಳ್ತಾ ಇದ್ದಾನೆ ನಾವು ಎಲ್ಲಾ ಮೆಟೀರಿಯಲ್ಗೆ ಅಂದ್ರೆ 2 wires ಗೆ ಮೂರು ಸೇಮ್ ಇದು L P ಸೇಮ್ ಅದ ಅಂತ ಹೇಳ್ತಾನೆ. So ds ಮಾತ್ರ ನೀವು ಕಂಡುಹಿಡಿಯಬೇಕು. ds you need to find out, right? So first we'll calculate the area now. We know that area of the copper wire AC pi by 4 wire ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾನೆ. ಡಯಾಮೀಟರ್ ಕೊಟ್ಟಿದ್ದಾನೆ ಅಂದಮೇಲೆ ಇದು ಸರ್ಕ್ಯುಲರ್ ಐತೆ ಅಂತ ಅರ್ಥ. So AC is equal to pi by 4 into DC square, diameter of copper wire. ಕೊಟ್ಟಿದ್ದಾನೆ copper wire problem ಅಲ್ಲಿ. So pi by 4 into 2 square. So this is equal to 3.142 mm square. ಇದು area. ಎದರ area ಇದು copper wire area. Similarly, area of steel wire na ಕಂಡಿಡೋಣ. So AS means area of steel wire. That is equal to pi by 4 into DS square. ಸೊ ds ನೇ ಕಂಡಿಡಿ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾನೆ ನಮಗೆ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ. ಇದು ಗೊತ್ತಿಲ್ಲ ನಮ್ಗೆ, ಅದು ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ಅದು ಹೆಂಗಿರುತ್ತೆ ಹಂಗೆ ಇಟ್ಬಿಡ್ರಿ. ಯು ಕೀಪ್ ಇಟ್ ಆಸ್ ಇಟ್ ಈಸ್. ಸೊ pi by 4 ಅನ್ನು ನೀವು ಮಾಡಿದ್ರೆ pi divided by 4 ಮಾಡಿದ್ರೆ ಯು ವಿಲ್ ಗೆಟ್ ಆನ್ಸರ್ ಆಸ್ 0.7854. ಸೊ ದಟ್ ಈಸ್ ds square as it is. ಯಾಕೆ ಗೊತ್ತಿಲ್ಲ ನಮ್ಗೆ, ರೈಟ್? ಸೊ ದಿಸ್ ಈಸ್ ವಾಟ್ ಯು ಹ್ಯಾವ್ ಸಾಲ್ವ್ಡ್ ಇಟ್ ನೌ. Then later on you solve this. So this means, so now see now we also know that increase in the length of the copper wire. Length of the copper wire means elongated. In the problem like elongated anta ಹೇಳ್ತಾನೆ. Elongated means change in the length. Change in the length in both the materials. Both the materials means whether it may be a steel or it may be a copper. So ಎರಡರಲ್ಲಿನೂ ಕೂಡ ಸೇಮ್ ಇದೆ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೆ ನಾವು. ಸೊ ನಮ್ಗೆ ಇದು ಫಾರ್ಮುಲಾ ಗೊತ್ತೈತಿ. ಸೊ ನಾನು ಹುಕ್ಸ್ ಲಾ ಹೇಳ್ಬೇಕಾದಾಗ ಈ ಫಾರ್ಮುಲಾವನ್ನು ಡಿರೈವ್ ಮಾಡಿದ್ದೆ ನಾನು. ಸೊ ಡಿಟ್ ಈ ಡೆಲ್ಟಾ ಎಲ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಪಿ ಎಲ್ ಬೈ ಎ ಇ ಅಂತ ಡೆರಿವೇಶನ್ ಮಾಡಿದೀನಿ ನಾವು. ಸೊ ಡೆಲ್ಟಾ ಎಲ್ ಈಗ ಸಿ ಬರಿತೀನಿ, ಯಾಕಂದ್ರೆ ಕಾಪರ್ ಕಂಡು ಹಿಡಿತಾ ಇದ್ದೀನಿ ನಾನು. ಸೊ ಐ ರೈಟ್ ಇಟ್ ಸ್ಮಾಲ್ ಸಿ. ಸೊ ಪಿ ಅಂಡ್ ಎಲ್, ಇಲ್ಲಿ ಪಿ ಸಿ ಮತ್ತು ಎಲ್ ಸಿ ಬರ್ದಿಲ್ಲ ನಾ. ಯಾಕೆ ಬರ್ದಿಲ್ಲ ಅಂದ್ರೆ ಪಿ ಮತ್ತು ಎಲ್ ಎರಡಕ್ಕೂ ಸೇಮ್ ಐತೆ ಅಂತ ಹೇಳ ನಾವು. ಸೊ ಅದಕ್ಕೆ ಐ ಕೀಪ್ ಇಟ್ ಆಸ್ ಇಟ್ ಈಸ್. ನಾ ಬರಂಗಿಲ್ಲ ಸಿ ಎಲ್ ಎನ್ ಸಿ ಅಂತ ಬರಂಗಿಲ್ಲ ಇಲ್ಲಿ. So now substitute all the values. AC ಕಂಡಿಡಿದ್ರಿ, EC ಕೊಟ್ಟನವ, substitute all the values. So PL divided by 3.142, this is the area of the copper wire, into EC means elastic modulus of copper is 100 into 10 to the power of 3. So PL divided by 314.2 into 10 to the power of 3. Keep this as equation number 1. ಇದನ್ನು 1 ಅಂತ ಇಡ್ತೀನಿ, ಯಾಕಂದ್ರೆ PL ಗೊತ್ತಿಲ್ಲ ನಮ್ಗೆ. ಸೊ ಸಾಲ್ವ್ ಮಾಡಕ್ ಆಗೋದಿಲ್ಲ ಇದು ಪೂರ್ತಿ. So I'll keep it this as equation number 1. And increase in the length of the steel wire. Steel wire alli increase ಎಷ್ಟಾಗ್ತದೆ? Same formula I'll apply here. Delta LS. Now S means steel wire. Again same PL by AS ES. PL is the same for both wires ಅಂತ ಕೊಟ್ಟಾನ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ. So AS ಕಂಡಿಡಿದ್ರಿ, write it. PL by 0.7854 ds square into ES. Young's modulus for steel material is 200 into 10 to the power of 3. So that is equal to PL by 157.1 into 10 to the power of 3 into ds square. Keep this as equation number 2. So this is the elongation for copper material. This is the elongation for steel material. But in the problem he is saying the elongation in both the wires is same ಅಂತ ಹೇಳ್ತಾನೆ ಅವನು ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ. ಎರಡು ಸೇಮ್ ಅಂದಾಗ you made it this one and this one equal. ಎರಡು ಈಕ್ವಲ್ ಆಗತ್ತೆ ಅವಾಗ. Delta LC is equal to delta LS ಅಂದಂಗ delta. So this is LC is equal to what is that? Delta LS. Delta LS ಎರಡು is equal to, ಇದನ್ನ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಕೊಟ್ಟನವ. ಯಾಕಂದ್ರೆ both are elongated of the same amount ಅಂತ ಹೇಳ್ತಾನೆ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ. ಸೊ ಅದಕ್ಕೆ since both the wires are elongated by the same amount, therefore equating equations 1 and 2 ಇವೆರಡು ಈಕ್ವಲ್ ಮಾಡ್ರಿ. So PL by 314.2 into 10 to the power of 3 is equal to PL divided by 157.1 into 10 to the power of 3 into ds square. Right? Avaga PL and PL cancel ಆಗುತ್ತೆ. So 10 to the power of 3 and 10 to the power of 3 cancel ಆಗುತ್ತೆ. ಏನು ಉಳಿತು ಈಗ? Just ಇದು ಈ ಕಡೆ ಉಳಿತದೆ, ds ಸ್ಕ್ವೇರ್ ಇಲ್ಲಿ ಇರ್ತದೆ ಈಗ. ಸೊ ಅವಾಗ ಇದು 1 ಇರುತ್ತೆ, ಮ್ಯಾಲ್ 1 ಇರ್ತೈತಿ. ಸೊ ಅವಾಗ ds ಸ್ಕ್ವೇರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 314.2 ಮ್ಯಾಲ್ ಬರುತ್ತೆ ಇಲ್ಲಿ. ಸೊ 314.2 ಮ್ಯಾಲ್ ಬರುತ್ತೆ. ಸೊ 157.1 as it is. So then after solving this, ds square you will get it as 2. Then ds is equal to square root of 2. So that is equal to 1.41 mm. So this is the answer. This is the diameter of the steel. ಇದನ್ನ ಕೇಳೋಣ, diameter of the steel. Right? ಇದನ್ನ ಕಂಡುಹಿಡಿಯಲಿಕ್ಕೆ he has given so many conditions there. ಏನೇನ್ ಕಂಡೀಷನ್ಸ್ ಕೊಟ್ಟಿದ್ದಾನೆ ಈ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ? ಲೆಂತ್ ಸೇಮ್ ಅಂತ ಹೇಳ್ತಾನೆ, ಲೋಡ್ ಸೇಮ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾನೆ, ಎಲಾಂಗೇಶನ್ ಇನ್ ಬೋತ್ ದ ವೈರ್ಸ್ ಆರ್ ಸೇಮ್ ಅಂತ ಹೇಳ್ತಾನೆ. ಸೊ ಆ ಕಂಡೀಷನ್ ತಗೊಂಡು ನೀವು ಇಕ್ವೇಟ್ ಮಾಡ್ಕೊಂಡು ಏನ್ ಮಾಡಬೇಕು? ಯು ನೀಡ್ ಟು ಫೈಂಡ್ ಔಟ್ ದಿ the diameter of the steel. So this is the problem. So next one we will see the problem number 10. So a load of 4 kilonewton is to be raised with the help of a steel wire. The permissible tensile stress should not exceed 70 Newton per mm square. What is the minimum diameter of the wire required? What will be extension for 3.5 meter length of wire? Assume Young's modulus is 196.2 giganewton per meter square. Giganewton per meter square. Newton per meter square is nothing but what? It is Pascal. Pascal na Newton per meter square antivi. Giga Pascal kodo badlagi giganewton per meter square anta kodana. Right? ಅದನ್ನ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಒಂದೊಂದ್ಸರಿ ಪಾಸ್ಕಲ್ ಕೊಟ್ಟಿರ್ತಾನೆ, ಒಂದ್ಸರಿ ನ್ಯೂಟನ್ ಪರ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಕೊಡ್ತಾನೆ. ನೀವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು ಅವಾಗ. Pascal and Newton per meter square both are same. Right? So problem ನೋಡ್ರಿ ಏನ್ ಕೇಳ್ತಾ ಇದೆ ನೋಡ್ರಿ. ಫಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ a load of 4 kilonewton is to be raised with the help of a steel wire. Right? ಲೋಡ್ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾನೆ ಇಲ್ಲಿ? 4 kilonewton ಲೋಡ್ ಕೊಡ್ತಾ ಇದ್ದಾನೆ. The permissible tensile stress should not exceed 70 Newton per meter square. This is the stress. Should not exceed antana. Should not exceed means this is the maximum stress. Is a maximum stress the material can withstand. Then what is the minimum diameter of wire required? Again he is asking minimum diameter of a wire also here. Right? And what will be the extension? What will be the extension means again he is asking delta L mat delta L kehtada. What will be the extension? Extension means delta L. Deformation means delta L. Elongation means delta L. ಮೂರು ವರ್ಡ್ ಅದಾವ ಅದಕ್ಕೆ. ದೆನ್ ಅಸ್ಯೂಮ್ ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್. ಅಸ್ಯೂಮ್ ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್ ಅಂದ್ರೆ ಇ ಕೊಟ್ಟಾನೆ. ಕ್ಯಾಪಿಟಲ್ ಇ he has given. Capital E is how much? It is 196.2 gigapascal. So write it the given data. Solution ಏನ್ ಕೊಟ್ಟಿದ್ದಾನಪ್ಪ? P load 4 kilonewton ಕೊಟ್ಟಾನೆ. So convert that into a Newton. So kilo means 10 to the power of 3, 1000 ಅನ್ನಂಗಿದೆ. So 4 into 10 to the power of 3 Newton. Then sigma is equal to 70 Newton per mm square. So length L is equal to 3.5 meter. So this meter converted into a mm. So it becomes 3500 mm. So E is equal to 196.2 giganewton per meter square. Got on. So if you convert this into mm square, it becomes 196.2 into 10 to the power of 3. 10 to the power of 3. 10 to the power of 3 Newton per mm square it is. Newton per mm square agate. So if you convert it into mm square, right? So to find minimum diameter of wire, idan first keltadane. Then extension delta L he is asking. So now sigma is equal to P by A. So now sigma cotton problem alli, right? P kottidana, but he has not given area. First find out area. So 70 is equal to load P is 4 into 10 to the power of 3 divided by A. So A is equal to 4 into 10 to the power of 3 divided by 70. So that will be 57.142 mm square. This is the area of the steel wire here. ಸೊ ಏನ್ ಕೇಳ್ತಾ ಇದ್ದಾನೆ, ಡಯಾಮೀಟರ್ ಕೇಳ್ತಾ ಇದೆ ನಿಮ್ಗೆ. ಸೊ ಏರಿಯಾ ಬಂತು, ಡಯಾಮೀಟರ್ ಕಂಡು ಹಿಡಿಬಹುದು ಈಗ. ಸೊ ವಿ ನೋ ದಟ್ ಏರಿಯಾ ಇಸ್ ಈಕ್ವಲ್ ಟು pi by 4d square ಅನ್ನಂಗಿದು. Pi by 4 means pi d square by 4 ಅನ್ನಂಗೆ. So now 57.142 because area ಗೊತ್ತೈತಿ, that is equal to pi d square divided by 4. So d is equal to square root of 4 area A by pi. So that is equal to d is equal to root of 4 into area is 57.142 divided by pi. So that will be 8.529 mm. So this is the diameter. So diameter ಕೇಳಿದ್ದ, diameter ಕಂಡು ಹಿಡಿದ್ವಿ, ಇಲ್ಲಿ diameter ಕಂಡು ಹಿಡಿದ್ವಿ. Then delta L. Delta L means extension, elongation, deformation. So that is delta L is equal to PL by AE. So this is equal to P is 4 into 10 to the power of 3 into L is 3500 mm divided by area is 57.142 into E is 196.2 into 10 to the power of 3. It is 196.2 10 to the power of 3. So ಇಲ್ಲಿ ನಾನು ಹೇಳಿದ್ನಲ್ಲ ಅವಾಗಲೇ, this is the one. So ಇದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಅಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿದಾಗ you will get the answer as 1.248 mm. This is the elongation, right? So the next problem is a mild steel bar of 15 mm diameter. This is mild steel bar of 15 mm diameter. ಎಲ್ಲಿ diameter ಕೊಟ್ಟನು, ಸೊ ಅದು ಯಾವ ರೀತಿ ಇರುತ್ತೆ, that will be a circular ಅನ್ನಂಗೆ. ಸೊ diameter ಕೊಟ್ಟಾಗ ಏರಿಯಾ ಕಂಡು ಹಿಡಿಬೇಕಾದಾಗ pi by 4 d square ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಬೇಕು. ಸೊ was subjected to tensile test. ಸೊ ಮೈಲ್ಡ್ ಸ್ಟೀಲ್ ಬಾರ್ 15 mm diameter ಇದ್ದಿದ್ದನ್ನ ನಾವೇನ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಟೆನ್ಸೈಲ್ ಟೆಸ್ಟ್ ಮಾಡಕತ್ತೀವಿ. ಸೊ ಟೆನ್ಸೈಲ್ ಟೆಸ್ಟ್ ಅಂದ್ಮೇಲೆ ಆ ಡ್ರಾಯಿಂಗ್ ಗ್ರಾಫ್ ನೆನಪು ಬರ್ಬೇಕು ನಿಮ್ಗೆ. ಸ್ಟ್ರೆಸ್ ಸ್ಟ್ರೇನ್ ಡೈಗ್ರಾಮ್ ಅಂತ ಹಾಕಿದ್ದೆ ನಾನು. ಸೊ ಅಲ್ಲಿ ಡಿಫ್ರೆಂಟ್ ಪಾಯಿಂಟ್ಸ್ ಇರ್ತಾವೆ. ಎ ಪಾಯಿಂಟ್ಸ್, ಪ್ರೊಪೋರ್ಷನಾಲಿಟಿ ಲಿಮಿಟ್, ಎಲಾಸ್ಟಿಕ್ ಪಾಯಿಂಟ್, ಅಪ್ಪರ್ ಈಲ್ಡ್ ಪಾಯಿಂಟ್, ಲೋವರ್ ಈಲ್ಡ್ ಪಾಯಿಂಟ್, ultimate point, breaking point. So these all the points you should remember whenever he says the tensile test here. The test bar was found to yield at a load of 90 kilonewton. This is a yield load. Yield at a load of 90 kilonewton. Yield load kotta iga. And it attains maximum load of 180 kilonewton. Maximum load kotta andre, so idu nenepidre nimge. So ಈ ಡ್ರಾಯಿಂಗ್ ಹೇಳ್ಬೇಕಾದಾಗ ಹೇಳಿದ್ದೆ ನಾನು. So this side is stress sigma and this side is what? This side is strain epsilon. So this is 0 point and this point is A point. ಇದು A point ಅಂತ ಹೇಳಿದ್ದೆ. So ಅದೇ ರೀತಿ ಇಲ್ಲಿಗೆ ಬಂದಾಗ at this point it is B point, right? It is B point. So at this point it is C point and this is a D. This is D point and here it is E and next this point is last point, this is F. So idanna study madivi now. A point is proportionality limit, B is elastic limit, C is upper yield point, D is lower yield point, E is ultimate point, F is fracture point. Yield at a load of 90 kilonewton ant kotana andre C point ಗೆ load kotana ಈಗ. And it attains maximum load of 180 kilonewton. Maximum load ಯಾವಾಗ ಅಟೈನ್ ಆಗುತ್ತೆ ಅವಾಗ, ಯಾವಾಗ ಇದು ಈ ಪಾಯಿಂಟ್ ಇರುತ್ತೆ ಅವಾಗ. This is ultimate point, that's the maximum point. And ultimately fails at a load of 67.5 kilonewton. Ultimately ಕೊನೆಯಲ್ಲಿ ಎಲ್ಲಿಗೆ ಬ್ರೇಕ್ ಆಗುತ್ತೆ ಅದು ಅಂತಂದ್ರೆ F ಪಾಯಿಂಟ್ ಕೊಟ್ಟಾನೆ. F ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಲೋಡ್ ಎಷ್ಟಿರುತ್ತೆ, 67.5 kilonewton ಇರುತ್ತೆ. So determine the following. ಇದನ್ನೆಲ್ಲ ಕೊಟ್ಟು ಏನ್ ಕೇಳ್ತಾ ಇದ್ದಾನೆ, tensile stress at the yield point, ultimate stress and stress at the breaking point if the diameter of the neck is 7.5 mm. 7.5 mm neck diameter ಕೊಡ್ತಾ ಇದ್ದಾನೆ. neck diameter ಅಂದ್ರೆ breaking point ಅಲ್ಲಿ neck formation ಆಗುತ್ತೆ. neck formation means it should come very short ಆಗಿ. So it should be something like this. ಹೆಂಗಿರ್ತದ, ರೈಟ್? ಸೊ ಯಾವಾಗ ಇಲ್ಲಿ ಈ ರೀತಿ ಆಗಿ ಇಲ್ಲಿ ಬ್ರೇಕ್ ಆಗುತ್ತೆ ಅದು. ದಿಸ್ ಇಸ್ ಇಲ್ಲಿ ಡಯಾಮೀಟರ್ ಬೇರೆ ಇರುತ್ತೆ, ಬಟ್ ಈ ಡಯಾಮೀಟರ್ ಕೊಡೋಣ ನಾವು ನಿಮಗೆ. ಈ ಡಯಾಮೀಟರ್ ಎಷ್ಟು ಇರುತ್ತೆ ಅಂತ ಕೊಡೋಣ, ಅಲ್ಲಿ 15 mm ಇರುತ್ತೆ ಅಂತ ಕೊಡೋಣ. ಬಟ್ ಈ ಪಾಯಿಂಟ್ ಹಿಂಗ್ ಸಣ್ಣ ಆಗಿ ಏನಾಗುತ್ತೆ, ಬ್ರೇಕ್ ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ ನಾವು ಗಿವನ್ ಡೇಟಾ, ಇನಿಷಿಯಲ್ ಡಯಾಮೀಟರ್ D is 15 mm, yield load is 90 kilonewton. 90 kilonewton means 90 to 10 to the power of 3 Newton. Ultimate load is 180 kilonewton that is 180 into 10 to the power of 3 Newton. So braking load is 67.5 kilonewton. So 67.5 into 10 to the power of 3 Newton. Final diameter is 7.5 mm. That is, this is the neck diameter. To find yield stress, ultimate stress, braking stress. So first you find out original cross sectional area. A is equal to pi by 4d square. So pi into 15 is the initial diameter. Original area candidate initial diameter thogobeku. So it is 15 square divided by 4. So that will be 176.7 mm square. So he is asking first parameter is yield stress, that is sigma y. So sigma y is equal to yield stress bandaga yield load togobek first, that is P by A. P means yield load divided by original cross sectional area. So that is sigma y means yield stress annanga. Y represent yield, sigma represents stress. Yield stress annanga. Yield stress is equal to 90 into 10 to the power of 3 divided by 176.7. So ಇದನ್ನ calculation ಮಾಡಿದಾಗ you will get it 509.3 Newton per mm square. So the next ultimate stress. Ultimate stress means ultimate ಬಂದಾಗ ultimate load by original area of cross section. So breaking, so now it is 180 into 10 to the power of 3. So divided by 176.7 is equal to again 1018.61 Newton per mm square. This is the ultimate stress. Then breaking stress. Breaking stress ಬಂದಾಗ breaking load ತಗೋಬೇಕು. Breaking load divided by original area of cross section. So again it is sigma b. B represents breaking, sigma represents stress. So it is breaking stress is equal to 67.5 into 10 to the power of 3 divided by 176.71. So solve this by using calculator. So you will get it 381.98 Newton per mm square. So this is the answer for breaking stress. But in this case, he has given the neck diameter. Neck diameter na velli use madilla. So neck diameter is a stress calculate madag elli use agangilla. You calculate any stress, whether it may be a yield stress, ultimate stress, breaking stress kandidibekadru, you have to take original cross sectional area only. Original cross sectional area ne ತಗೋಬೇಕು. Initial diameter ಏನು ಕೊಟ್ಟಿರ್ತಾನೆ ಅದನ್ನೇ ತಗೋಬೇಕು. ಯಾವಾಗ ನಿಮಗೆ ರಿಡಕ್ಷನ್ ಇನ್ ಏರಿಯಾ, ಪರ್ಸೆಂಟೇಜ್ ರಿಡಕ್ಷನ್ ಇನ್ ಏರಿಯಾ ಅಂತ ಹೋಗ್ತಿರೋ ಅವಾಗ ಆ ನೆಕ್ ಡಯಾಮೀಟರ್ ಯೂಸ್ ಆಗುತ್ತೆ ಅವಾಗ. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ ಅಲ್ಲಿ ಫಾರ್ಮುಲಾ ಬರುತ್ತೆ. ದ ಫಾರ್ಮುಲಾ ಇಸ್ ಎ ಇನಿಷಿಯಲ್ ಮೈನಸ್ ಎ ನಾಟ್ ಡಿವೈಡೆಡ್ ಬೈ ಎ ನಾಟ್ ಅಂತ ಹೇಳಿದ್ದೆ ನಮ್ಗೆ. ಸೊ ಅವಾಗ ಪರ್ಸೆಂಟೇಜ್ ರಿಡಕ್ಷನ್ ಏರಿಯಾ ಅಂತ ಬಂದಾಗ ಮಾತ್ರ ನಿಮ್ದು ನೆಕ್ ಡಯಾಮೀಟರ್ ಯೂಸ್ ಆಗುತ್ತಾ, ಇಲ್ಲಾಂದ್ರೆ ನೆಕ್ ಡಯಾಮೀಟರ್ ಯೂಸ್ ಆಗೋದಿಲ್ಲ. You have to take all original area of cross section only. So next is of the this is also same. The following data pertains to a tension test. Once again tension test conducted in laboratory. Diameter of the specimen is 20 mm. Initial diameter again. Gauge length of the specimen is 100 mm. So then the final length is 130 mm. So this is 100 mm is the actual dimension, actual length it is. Final length 130 means after breaking. Load apply ಮಾಡಿ tension ಆದ್ಮೇಲೆ break ಆಗುತ್ತಲ್ಲ, break ಆದ್ಮೇಲೆ 130 ಬರುತ್ತೆ. Final diameter is 11.5 mm. Final diameter means it is neck diameter ಇದು. Yield load ಕೊಟ್ಟಾನ 92 kilonewton. Ultimate load is 165 kilonewton. Determine yield stress, ultimate tensile stress, percentage elongation, percentage reduction in area. Note, ಈ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ purposefully I have taken percentage reduction in area ಬೇಕಂತ ತಗೊಂಡಿನಿ, ಯಾಕಂದ್ರೆ ಗೊತ್ತಾಗಬೇಕು ನಿಮಗೆ. So final diameter ಎಲ್ಲಿ ಯೂಸ್ ಆಗುತ್ತೆ, right? So again if you write it same, first you find out the original cross sectional area. So that is A is equal to pi d square by 4. So pi into 20 square by 4, that is 314.15 mm square. This is the original cross sectional area. So yield stress kadana write yield stress. Sigma y is equal to, as I told you, yield load by original cross sectional area. So 92 into 10 to the power of 3 divided by 314.15. So it is 292.8 Newton per mm square. This is the yield stress. Similarly, ultimate stress. Ultimate stress ಕಂಡಿಡಿದಾಗ ultimate load by original cross sectional area. So ultimate load he has given 165 kilonewton. So 165 into 10 to the power of 3 divided by area, again same original cross sectional area. So this is equal to 525.2 Newton per mm square. Final area of cross section, final area ಕಂಡುಹಿಡಿಯಬೇಕು. ಎದಕ್ಕೆ ಬೇಕಾಗುತ್ತದೆ ಇದು ನಿಮಗೆ percentage reduction in area ಕಂಡುಹಿಡಿಯಾಗ. So it is pi d1 square by 4 pi into 11.5 whole square divided by 4, that is 103.86 mm square. So percentage elongation, it is LF minus L0 by L0 into 100. LF means final length, L0 is original length. So 130 is the final length given in the problem. 130 minus 100 is initial length. It is a gauge length. It is a gauge length he has given. That is the original length. 130 minus 100 divided by 100 into 100. So that is 30%. Now 30% is the percentage elongation. Percentage reduction in area, A0 minus AF divided by A0 into 100. A0 is original cross-sectional area, AF is final. So 314.15 is original cross-sectional area minus 103.86 is final cross-sectional area, means after breaking. So divided by 314.15 into 100 is equal to 66.9%. This is the 66.9% is the percentage reduction in area. This is what he is asked in the problem. So right. So next, this is a problem 13. So problem 13 is also of a hollow steel column, right? This is related to hollow steel column, has to carry an axial load of 3 mega Newton. Mega Newton means 10 to the power of 6 Newton it is. If the external diameter of the column is 300 mm and the internal diameter, the ultimate stress for steel is to be 480 Newton per mm square. So this is the maximum stress. The take factor of safety as 4. Factor of safety is telling you to take 4, right? So these are all the given data. Write the given data now first. So what he is asking only internal diameter. Internal diameter ಕೇಳ್ತಾದಾನೆ ಯಾಕಂದ್ರೆ this is a hollow column. Hollow means it has external and internal. So you need to find out working stress. Working stress is equal to ultimate stress divided by factor of safety. It is 480 by 4. So it is 120 Newton per mm square. So we know that sigma T is equal to P by A. So if it is P by A, substitute all the values here again. So you will get the area A. So now area, you know, for the hollow cylinder, it is pi by 4 D0 square minus DI square. So by substituting the values in above equation, illi substitute madre values, area ಕಂಡುಹಿಡಿದ್ರಿ, area value ಹಾಕ್ರಿ. So D0 means outer diameter is given in the problem, substitute there. DI ಒಂದೇ ಗೊತ್ತಿಲ್ಲ, ಅದೊಂದು ಬಿಟ್ಟು ಎಲ್ಲ substitute ಮಾಡಿ, then you find out in the calculator, you will get as DI is equal to how much? 241.18 mm. So this is the internal diameter. So for this problem, I have referred the RS Kurumi book, right? Okay, thank you. This is the end of the our